All right, let's jump into this deep dive. Think for a moment about, one of the biggest turning points in Earth's history, the dinosaur extinction. For ages, the story we've all heard is pretty straightforward, almost like a cosmic lottery win, right?
Yeah.
Asteroid hits, boom, mammals get their chance, and, well, eventually here we are, figuring out Wi-Fi passwords. It's a neat story, a lucky break for us.
It is compelling, yeah. That idea of chance paving the way.
But what if that isn't the whole story? What if there's another way to look at it entirely? Today we're digging into something called motion theory, and its core idea is, well, it's pretty radical. It suggests life isn't just some random biological fluke.
Exactly. It posits that life is more like a natural result of what the theory calls stable sync conditions.
Stable sync conditions, like rhythms.
Yeah, specific environmental rhythms, think temperature cycles, atmospheric changes, that sort of thing. When those conditions are right, life's own internal rhythms can lock into a persistent self-reinforcing pattern. The analogy they use is like crystals forming. They only form under very specific pressures and arrangements, right? Life's a bit like that, but with motion and rhythm.
Okay, interesting. So the big question we're asking you to think about today is this. What if that asteroid just missed? What if the dinosaurs' way of being, their sync stack, as the theory puts it, their whole established way of meshing with the planet, just kept going, remained the dominant planetary rhythm?
Yeah, imagine that alternate timeline.
We're going to explore that universe where the extinction event never happened and what that really means for, well, for us, for our existence, and maybe even for how we should be looking for alien life.
It really starts with how motion theory defines life itself, which is quite different.
How?
It boils it down to motion resolving into self-sustaining nested loops. It's less about chemistry initially and more about physics, about patterns of movement. Think of a really stable whirlpool. It's constantly moving, fluid is flowing through it, but the form, the loop itself, persists. It sustains itself through that organized motion.
Okay, self-sustaining motion loop, that's very fundamental.
It is. And it views life not as just a complex chemical reaction, but as this fundamental property of motion finding stability.
So if life starts as these basic loops, how do you get from that to, a T-Rex or a whole complex ecosystem? Is it just stacking loops?
Essentially, yes. It's framed as a natural layering process. Complexity isn't planned, it just sort of emerges. These initial loops, they layer up, they interact, they refine themselves recursively, like building blocks getting more and more intricate, with each new layer influencing the ones before and after.
Recursively, meaning they loop back on themselves.
Exactly. And here's a really key concept in the theory. Recursive loop dominance locks in.
What does that mean, locks in?
It means when a species or an ecosystem adapts really well to its environment, its way of syncing becomes incredibly efficient. So efficient, it's like a river carving a super deep canyon. That pattern, that sync, becomes the path of least resistance. It's incredibly stable, very hard to change or deviate from. It just keeps reinforcing itself.
Right, which sounds exactly like what the dinosaurs might have achieved over millions of years.
Precisely. And this leads to one of the theory's most provocative ideas.
Which is?
That maybe dinosaurs weren't some weird prehistoric phase. Maybe they represent the expected evolutionary direction for most habitable planets.
Oh, okay, the default setting for life, dinosaurs.
Kind of, yeah. The idea is that their way of syncing with the planet was just so incredibly effective.
What made them so good at it? What specific syncs are we talking about?
Well, think about their massive bodies. In many cases, they were likely in thermal sync with the environment. Their size helped them buffer temperature changes, almost becoming part of the planet's thermal rhythm rather than fighting it constantly.
Passive temperature regulation.
Okay, and then you have the predator-prey dynamics. These incredibly tight rhythm response cycles, constant adaptation, movement, reactions, shaping each other's patterns over generations. Their whole physiology, their behavior, it was all just perfectly tuned into the specific conditions of Earth during the Mesozoic era. They found the groove.
And that kind of deep sync, as you said, it doesn't just fade away.
No, it self-reinforces. It builds deeper and deeper sync harmonies over millions of years. It becomes less like just life on the planet and more like a fundamental rhythm of the planet itself.
That sounds incredibly stable, almost permanent if left undisturbed.
Exactly. Which brings us to the conditions needed for life, according to this theory, the motion thresholds.
Right, you mentioned those. What are they? What does a planet need for this kind of rhythmic life to not just start, but, last?
Okay, so the theory lays out three core ones. First, you need thermal rhythm. Temperature changes, yes, but within a consistent, predictable range, like a steady beat.
Not too hot, not too cold, but regular ups and downs.
Exactly. Second, atmospheric motion. The pressure, the composition, the air circulation, it all needs to sort of harmonize with the internal rhythms of cells, of life. Think of it like the planet's breathing needing to be in sync with life's breath.
Okay, and the third?
Radiation balance. Basically, the energy from the star. It needs to be steady, providing enough energy without being overwhelming or erratic. A consistent hum, not sudden bursts or drops.
So when those three things line up.
That's when, the theory suggests, life ignites as recursive motion adaptation. It's life's motion finding that perfect dance partner in the planet's rhythms.
But igniting is one thing, persisting is another. What keeps it going?
Ongoing stability. The planetary rhythms need to stay relatively stable. No huge catastrophic sync disruptions.
Like a giant asteroid impact.
Precisely. And critically, the life system itself, the motion stack, needs to remain stable. It shouldn't evolve in a way that destabilizes its own foundation.
And the point is, the dinosaurs, they kicked all those boxes, right? They had the stable planet, they achieved the deep sync.
They really did. But humans, our current system, maybe not so much. We're introducing a lot of rhythmic instability ourselves.
That's a sobering thought. Okay, so let's dive into that alternate world. Asteroid sails on by, dinosaurs keep evolving. What does motion theory predict happens next? Not necessarily intelligence, you said.
Right. The trajectory isn't towards higher cognition as we think of it. It's towards refined biological rhythm.
Refined rhythm. What does that look like in practice?
Think of life just becoming incredibly, almost unimaginably efficient at being. Megafauna developing increasingly efficient motion loops. Their metabolisms, their movements, their resource use, all becoming perfectly optimized, wasting almost no energy, perfectly integrated into the environment's flows.
Less thinking, more flowing.
Kind of. Imagine long-term species memory, not stored in complex brains, but somehow encoded in sync patterns throughout their biology, passed down generationally through these rhythmic interactions.
Wow. Like instinct, but on a planetary scale.
Perhaps. Maybe even evolving towards a kind of bio-network of shared rhythmic communication, some sort of early, subtle neural resonance connecting organisms across the ecosystem. A living symphony.
So, no cities, no tools, no fire.
Probably not. No Wi-Fi, definitely no podcasts.
A terrifying prospect. But seriously, it would be a world of what the theory calls biological perfection. Evolution just keeps refining the existing rhythm, never needing that hard reset.
A world perfectly in balance, biologically speaking.
Okay, but if that's the default, the stable state, then how on earth did we happen? Our intelligence, our technology, it feels like the complete opposite of that seamless biological rhythm. What broke?
Well, that's the twist, isn't it? Motion theory offers this really counterintuitive idea here.
Which is?
Recursive loop collapse equals creative phase space.
Okay, break that down.
Basically, when a super stable system like dinosaurs' dominant sync collapses catastrophically.
Like with the asteroid impact.
Right. It doesn't just vanish. It shatters the dominant rhythm, creating this chaotic, unstable, rhythmic void. All the old rules of motion are broken.
And into that void.
New sync experiments can begin. Things that couldn't get a foothold before because the dominant rhythm was too strong. That's where mammals, lurking in the background, suddenly had opportunities. This instability, this void, is potentially what drove the rapid evolution towards different strategies, including higher cognition, complex problem-solving, communication, storytelling, eventually science.
So intelligence isn't the goal of evolution in this view?
Not necessarily. It might be the recovery mechanism of a sync-shattered system. We didn't get smart because it was inevitable. Maybe we got smart because the planetary music stopped, and we had to figure out how to make our own in a much more conscious, flexible way.
We're the result of a broken rhythm.
That's one interpretation, yeah. A creative response to chaos.
Okay, that completely changes how you might think about looking for life elsewhere.
Absolutely.
Yeah.
If this theory holds water.
Then searching for Earth-like planets that didn't have a major extinction event, planets where the original dinosaur-like sync might still be dominant.
You might not find cities or technology. You wouldn't be looking for radio signals necessarily.
What would you find instead?
You might find these planet-wide sync ecosystems, dominated by what the theory calls super-evolved, non-intelligent apex bioloops.
Super-evolved bioloops.
Right.
Like perfectly efficient biological machines.
Exactly. Life forms that are the absolute peak of biological integration with their planet. They never needed to innovate because nothing ever broke. They achieved stability and just stayed there, refining the rhythm.
They never left the garden, so to speak. They never exited that original loop.
That's the idea. A planet teeming with incredibly complex, efficient life, but perhaps no intelligence or technology as we understand it at all.
So let's just recap the core idea here. Motion theory argues the asteroid wasn't just clearing the state for us.
No, it argues the asteroid interrupted a universal default.
Dinosaurs, or something like them, might be the norm. The long-term stable state for life on many planets, this self-balancing biological rhythm machine.
And we humans, we're maybe not the pinnacle, but more like the interesting, perhaps fragile result of that machine breaking down and life having to improvise.
Wow. Which leaves us, and you listening, with that really profound question from the source material to chew on.
Yeah? What kind of universe are we in, if they were never supposed to?
If the dinosaurs were the intended outcome, the stable state, what does that make us? Think about how that reframes evolution, our place, maybe even our future here in the cosmos.